All right, everyone, this is our final review of the year, and this would cover Unit 1, which is all about finance. So the first thing we did way back when was we talked about how a ledger or a balance from, let's say, a checking account would look and how you'd figure out these missing values. So basically what you see here are descriptions of where a purchase was made or when a deposit was made. And remember, purchases will take away money from your balance, whereas deposits will add to it. So it almost works on a diagonal method. Like you had some amount of money, X, you spent it at Target, and then it equaled 215.23. So when you're asked a question like part A, that's sort of what you see in blue here. X minus 175 equals the 215. So whether you write it as an algebraic equation or not, the main thing you had to do here was kind of work backwards. So if you're spending money and you're trying to figure out what you had to begin with, you'd actually have to add those two to figure out what that amount was before. Or just think about it. If you spent money, you will end up with less. You can't end up with more. So you have to figure out what you had to start with because now you only have 215. So if you add those, you discover that you had $390.37 before you spent money at Target. Now the second question says you spent some money at Marshall's. We don't know what it was, but you had 215, you spent it, and now you have 187. So in this case, you'd actually have to, and again, you can see the algebraic work here where I kind of put a star, but you'd actually have to subtract. You're trying to figure out between these two numbers, what amount did you spend that brought you down from 215 to 187? So whether, again, you do it algebraically or you just think about it, you spent $28.07. And lastly, it says you deposited money. So that just means you had this balance, you added this, what do you now have? And you would add the two and you have 310.62. So that's, again, if you get confused in the equations I wrote right here, just think about it in real life. Like, honestly think, if you were to, like, have this amount of money, you obviously spent something, you have less money, what's that amount you spent? Or what did you have prior to going to Target? Or what do you have after you make a deposit? And I think you could figure it out and check your work. Okay, another thing we talked about in Unit 1 was slope-intercept form relating to a real-life question. And if you remember, slope-intercept form, that's y equals mx plus b. M is always the slope. B is the y-intercept. And in a real-life context, the slope is the hourly rate or some type of thing that says per. So $45 per hour, that's the rate in which you are being charged. The upfront cost or the initial amount is always the y-intercept. That's why our equation looks as it does right here. And then when it says plumber works a total of 3 hours, that means you'd plug in 3 right here for X because you're being charged $45 per hour. So you'd multiply that by 3, add on that given 300 that you have to pay, and that's how you get that total of 435. All right, another thing we did was different types of interest formulas. Now, right here, you can see simple interest. That's if I just want to know the interest made, which is always a small amount and some amount added on to the principal. And that formula is just PRT. And if you forgot what any of these things stand for, that's what this part is over here, reminding you what everything stands for. So P or principal is always that initial amount of money. R is always the interest rate, and very important to remember it's as a decimal. You'll see that throughout these notes. Time is always measured in years. So here we go, and that's universal for all of these formulas. So that was simple interest. Future value is actually like saying, okay, take the principal and add on the interest and tell me what you'd have. So that's what this formula is saying. It's like the future overall amount of money. And lastly, if there was compound interest involved, which is more likely in a lot of real life scenarios, simple interest isn't always talked about. Compound interest is, or they change it into a simple interest question. But the compound interest formula has one extra piece to it. It has this N. And N stands for how often interest is calculated. We sometimes call it the number of compoundings. And that's what this whole thing right here is. So if you see an account that charges or earns you semi-annual interest, that means twice a year you will earn interest. If it's quarterly, that means 4 times a year interest will be calculated. And if it's monthly, 12 times per year. So what you see here is just a variety of questions, some pertaining to simple interest, future value with simple interest, or future value with compound interest. But sometimes there's a trick, and that trick is sometimes you're looking for the future value. You're looking for A. Other times you're looking for the initial amount, which is like saying find the principal, and you'll have to work backwards in those. So let's take a look at these questions and see which ones are straightforward plugging in and others are working backwards. So for numbers 4 and 5, these are straightforward. Find the simple interest, and then I just plugged in P, R, and T. Notice this little note right here. Let me highlight it instead. This is how you always change interest rate to a decimal. You either move the decimal to the left 2 spaces or divide it by 100, whatever makes more sense in your brain. But you always have to change that percent into a decimal. Otherwise, all of your work would be incorrect. So the amount of interest earned in this case is $7.50, and that makes sense. Interest is always some smaller amount added on. Now, the next one says find the future value of a car loan. So this isn't just saying what's the interest, this is saying what's the overall amount. So if you are financing a car at $6,500 and you're agreeing to pay it off for 7 years, what you're actually spending, and that's what future value tells you, is $8,206.25. So future value tells you what you owe, which is definitely $6,500, and it adds on the interest for you, so you can see the overall amount with the interest calculated in as well. Now, some of these questions that follow say find the initial amount. So notice I wrote right here a division sign because you're going to have to divide. So what you see for the work here is I want to have a future value of 750. That's why 750 is here. That's like saying I found A. I plug in everything else as normal, and then I just have to divide. So if I were to calculate 1 plus, and then the quantity 0.015 times 20, that's 1.3, and I had to divide to find that. So if you're ever looking for initial amount or principal, it's always going to be lower than the future value. So the idea here is if you want to earn money, like you want to have $750 in the bank 20 years from now, and you have simple interest of 1.5%, what do you have to put in today to make that happen? You have to put in $576.92. All right, so moving on to our next one. Find the future value. Now here's compound interest. And compound interest has that added piece to it, remember? So you have principal of 900. You have the interest rate as a decimal, but notice you have 12 in those 2 spots. Compounded monthly, that's what that stands for. That's not this 12. This 12 is years. That's what this 12 represents. But the compounding amount is what you have to put into the spaces I highlighted. Now again, if you try and type that all into a calculator, be careful. There's a lot of parentheses. You might want to break it into component pieces. But you can see that your future value actually goes up quite a bit with compound interest because you're calculating interest more often than just once. And simple interest always calculates it on that same principal amount. Compound interest is like earning interest on your interest. It continues to add on to your amount and recalculates interest from that. So that is how you would type into that. The next question points out how to do finding the initial amount. So for this last one here, number 8, same thing. I plugged in everything here. I want 325. I don't know the initial amount, 0.055. And then notice there's a 2 in both of those spots. And that's because it is semi-annual interest. Okay, so I calculate everything on the right-hand side next to P, and I get 1.24, which I then divide into 325 to get my answer for P. Now, future value with compound interest is often used in a lot of word problems, and this one here, number 9, is an example of that. So one thing we talked about in class were down payments. So if the principal is supposed to be $3,000 but you agree to pay $500 up front, that drops the principal by that amount. So now you're really financing $2,500 for this mattress. Then it says you agree to a plan for 7.5% interest compounded monthly. You want to pay it off in 4 years. That's the work right here. So this new principal amount of $2,500, there's your interest rate, there's the compounded monthly, and there's the 4 years. And this is what this is what you're actually paying. So again, we saw this with student loans, with cars, and here with a mattress. Although it's a $2,500 mattress, because you're not paying it all right away, you're agreeing to pay it off over the course of 4 years, you're actually going to spend $3,371 on this mattress. And again, we talk about how that's unfortunate, but the bank that's loaning you money or the store that's loaning you a line of credit has to know that you're going to pay it back. They don't want to just give you money and say, yeah, pay it off whenever, and then you don't pay it off. So they have to charge you some type of service amount, and that's what the interest is in this case. So then what we learned was, once you know the future value you're going to have to spend, if you know it's going to be 48 months, because that's 12 months in a year, 4 years, this is how they devise a monthly payment for you. They say, okay, you're going to be basically paying $3,371.50. You're going to pay that off in 48 payments. So each payment will be $70.24. So it kind of lessens the burden. Instead of paying $2,500 right now and then not having a lot of money, you could just agree to pay $70.24 a month. And even though you'll spend more in the long run, it makes it more affordable in the short run. All right, and the very last thing we had was credit card situations here. Now, these are a little bit more complex, so I've shown you the formulas that would go into these and how you would calculate it. And what we talked about was similar to the mattress problem. Sometimes you have a balance on your credit card. Maybe you can't pay it all off right away. So there's interest that gets calculated onto your remaining balances. Now, to be nice, the credit card company is not going to just charge you interest the day you had the biggest remaining balance. So let's say you made a big purchase at Amazon. It wouldn't be fair for them to just randomly pick that day as the day they calculate all of your interest. So they do something called a daily periodic rate. And what a daily periodic rate is it basically is this APR percent, which is advertised. They tell you that always. Again, the lower the APR, the better for you. So APR is the interest rate that they are charging you, but they're dividing it out over 365 days. So really, it's not 19%. It's kind of like 0.05. Now, notice when we calculate that daily periodic rate, we leave the APR number as is. You don't change that to a decimal. It's the one time you kind of leave it. We deal with that, changing it into a decimal later. So you basically just take the number as is, 19.35, divide by 365, and you get 0.05. We will use that later. Now, the next thing they do, because I said again, it wouldn't be fair for them to just pick one random day and multiply that interest amount by that balance. They determine something called your average daily balance. So this is like a weighted average. You basically are going to multiply the number of days you had a particular balance times the amount of balance or money you had that day, and you do that for each different one and divide by the total number of days in that billing cycle. So what I mean by that, if you look here, you can see the first one, 5 times 9.45. So that's like saying there were 5 days when you had a remaining balance of $9.45. Okay? Then, if you keep going, there were 7 days when you had a balance of $22.55. Just like there were 8 days you had a balance of $378.70. So you keep multiplying the number of days by the balance and then divide it by the total number of days, which I just added those in the left column there. That's 30. And what the credit card company would say is, okay, over the course of a month, 30 days, you sometimes owed a little bit of money, you sometimes had a huge remaining balance, but on average, a weighted average said you typically had $167.39 as your balance. So what they basically say is, if we're going to charge you interest, this daily periodic rate, I'm going to base it on this number, not on some random day they just chose. They're going to base it on this kind of like moving weighted average. And what you do to figure out the amount you'd actually be charged in interest is this formula in green. They take that daily periodic rate from part A. Now you put it over 100. You then take the average daily balance you found and the number of days in the billing cycle, which was 30, and you come up with this number, which is a little bit more manageable. So what they're basically saying, what the credit card company does, is they say, okay, over the course of a year, we're going to do a daily periodic rate of 0.05. Okay. Now, you in this particular billing cycle, these 30 days, you had an average daily balance left over that you hadn't paid off of $167.39. And if I plug that into this formula here, for that billing cycle, you will be charged an additional $2.51 interest. Not so bad. $2, yeah, it stinks. That gets much higher if you have a much larger balance and you don't pay your credit card off. But that's how that gets calculated, and that's how they add that little interest charge on it. So there you have it. That was Unit 1, everybody. Please go through this and do your best to answer the study guide.